In almost every World War II movie, when someone shoots a soldier carrying a flamethrower, the fuel tanks explode in a massive fireball. Bodies fly, flames erupt. The operator's buddies dive for cover. There's just one problem with that scene. It's complete fiction. But here's what makes this fascinating. American soldiers in 1943 believed the Hollywood version too. Marines on Iwo Jima were so convinced their flamethrowers would explode when hit that some conducted unauthorized field tests, shooting their own fuel tanks with .30 caliber rifles. Japanese soldiers targeted flamethrower operators first, not because hitting the tanks caused explosions, but because these men were the most feared weapons on the battlefield. So what actually happened when you shot a flamethrower tank full of napalm? Why didn't 68 pounds of thickened gasoline strapped to a soldier's back turn into a bomb? And why did the US Army spend years trying to convince their own terrified troops that their equipment wouldn't kill them? The answer involves basic chemistry, inert gases, and one critical design choice that Hollywood still gets wrong today. Welcome to World War II Objects, where every object tells a story. Hold an M2-2 flamethrower fuel tank in your hands. It weighs 68 pounds when loaded, more than half the body weight of the average 1940s soldier. Inside that dark green cylinder sits 4 gallons of thickened gasoline, a sticky napalm mixture that clings to surfaces and burns at 2000 degrees Fahrenheit. Now here's the critical part that every war movie ignores. Compressed inside a separate compartment sits nitrogen gas at 300 to 375 psi. Not oxygen. Not compressed air. Nitrogen, one of the most inert, non-reactive gases on Earth. Think of it like a can of whipped cream. When you press the nozzle, nitrogen propellant pushes the cream out under pressure. The cream doesn't explode because there's no oxygen inside the can to support combustion. The M2-2 worked exactly the same way, except instead of cream, it was jellied gasoline, and instead of your dessert, it was heading toward an enemy bunker at 40 yards per second. For something to explode, you need 3 things: fuel, an oxidizer, and an ignition source. The flamethrower had fuel. It had an ignition source at the nozzle, a small electrical spark plug that lit the stream as it left the wand. But crucially, it had no oxidizer inside the tanks. The nitrogen couldn't support combustion. The fuel couldn't access oxygen while sealed in the tank. When a bullet punctured that tank, physics took over. The pressurized fuel would spray out like water from a punctured garden hose. Sometimes it would ignite if it hit something hot or if the operator was actively firing. But it couldn't detonate. Detonation requires rapid expansion of gases in a confined space with an oxidizer present. None of those conditions existed. Chemical Warfare Service engineers tested this extensively at Fort Benning in 1943. They shot fuel tanks with every caliber of weapon available: rifles, machine guns, even tracer rounds designed to ignite flammable materials. The result, every single time, fuel leaked or sprayed. Sometimes it caught fire, but never once did a tank explode. But here's what soldiers didn't know. Here's what made flamethrower operators priority targets. Not the explosion risk, but the psychological terror they inflicted. Picture this. You're a Japanese soldier in a reinforced cave on Okinawa in May 1945. You've survived artillery bombardment, rifle fire, and grenades. Then you hear it, that distinctive whooshing roar like a giant industrial blowtorch. Through the cave entrance, you see bright orange-yellow flame shooting through the darkness, trailing thick black smoke. The smell hits you, heavy, oily, choking. Burning gasoline mixed with napalm thickener. That flame sticks to everything it touches: stone, metal, flesh. One Marine Corps after-action report describes Japanese soldiers screaming, "Flame! Flame!" and surrendering before the operator even pulled the trigger. But the weapon didn't need to work. Just appearing with it was enough. That's why enemy forces shot flamethrower operators first. Not because hitting the tanks caused explosions, but because killing the operator eliminated the most psychologically devastating weapon on the battlefield. Now you might be thinking, surely some tanks must have exploded from all that combat. Thousands of flamethrowers saw action in the Pacific. Operators faced casualty rates 2 to 3 times higher than regular infantry in intense combat. With all those bullets flying, wasn't there at least one documented explosion? Here's the thing. Army Ordnance Safety Bulletin 47, issued in 1944, specifically addressed this myth. The bulletin examined every reported flamethrower incident across all theatres. 0 confirmed fuel tank detonations from small arms fire. None. The closest thing to an explosion was when a nitrogen propellant tank took a direct hit at the perfect angle and ruptured violently, but that was high-pressure gas escaping, not the fuel exploding. And those incidents were extraordinarily rare because the propellant tanks were smaller, reinforced, and positioned low on the pack frame. What actually killed operators was being slow-moving targets. At 68 pounds, you couldn't run fast. You couldn't take cover quickly. And when you fired, that bright orange flame pointed straight back to your position like a neon sign saying, "Shoot here." Effective range was just 20 to 40 yards, meaning you had to get close enough that the enemy you were attacking could easily shoot back. But that's not all soldiers feared about their equipment. You might be wondering, if the science is this straightforward, now why does the explosion myth persist 80 years later? In February 1945, on Iwo Jima, a group of Marines conducted an unauthorized experiment. Convinced their flamethrowers were ticking time bombs, they took turns shooting each other's fuel tanks with .30 caliber rifles during a lull in combat. According to Marine Corps Historical Division oral histories, here's what happened. Fuel sprayed everywhere under pressure. Some of it ignited from nearby positions, creating dramatic flames. The Marines dove for cover, hearts pounding, but no explosion, no fireball, no flying shrapnel. They were relieved. They were also still terrified of being targeted, because now they understood. The danger wasn't their equipment exploding, it was being marked for death the moment they picked up the weapon. Corporal Howard Baxter, 4th Marine Division. It later recalled, "Everyone thought if you got hit, the tanks would blow. Never happened. Saw 3 guys take rounds to the tanks. Fuel leaked everywhere but no explosion. They were more worried about burning than blowing up." So why does Hollywood keep showing explosions? Because fire alone doesn't read dramatically on screen. A slow fuel leak, even if it ignites, looks like equipment failure. But a massive fireball? That's visual storytelling. It communicates danger instantly. And once that image entered popular culture through 1950s and 60s war films, it became the truth that everyone remembers. There's also psychological confirmation bias at work. Operators knew they were priority targets. When an operator was killed, survivors remembered the danger, the targeting, and the fear, and their brains filled in the explosion that fit their expectations, even though it never happened. Modern militaries still use incendiary weapons based on the same principle: fuel plus inert propellant plus separate ignition. The M202 flash rocket launcher introduced in Vietnam used the same chemistry. No oxidizer in the fuel compartment means no explosion risk from puncture. The fundamental design endures because the physics haven't changed. So the next time you watch a World War II film and see a flamethrower operator get shot, watch what happens to those fuel tanks. You'll know it's not just Hollywood taking creative license. It's a myth born from genuine fear. It's proof that even trained soldiers believe their own equipment could kill them. It's a reminder that sometimes the most persistent legends come from the gap between what we feel and what chemistry actually allows. Thank you for watching WW2 Objects. If you have suggestions for other WW2 items we should cover, From unusual uniforms to forgotten tools to surprising weapons, leave them in the comments below and we'll give you a shout out. Don't forget to like, subscribe, and hit the bell so you never miss a story from the battlefield.